Howard Wiig is an EAH past president, talks about reflective roofs and walls, including non-white coatings. Coatings are perhaps the most resource-efficient and cost-effective means of cooling Hawaii's homes and buildings. Howard has been the state's leader in drafting Hawaii's energy code for the last 30-plus years, which includes the latest recommendations and requirements on energy-saving coatings for buildings and homes. The title for his talk is Reflections on Reflectivity. Howard is also the host for the podcast Code Green with ThinkTech Hawaii.
Okay, it's a pleasure to start our meeting today. Aloha and welcome to everyone here and also online. This is the March 15th meeting of Engineers and Architects of Hawaii. I am Barbara Rogers, serving as first vice president, and I'm stepping in for Kanan Shaw, who is not able to be with us today. Thank you so much for joining us. I'm sure Mac has his humor ready for us. Mac?
Well, I dug into the EAH treasure of jokes in desperation, and I saw a sign that I thought you guys would enjoy. It said, "It's strange how drinking 8 glasses of water a day seems impossible, but 8 cups of coffee goes down like a chubby kid on a seesaw."
Thank you so much. Our speaker this morning, Howard Wiig, is also the program chair for this month. He's an energy analyst with the Hawaii State Energy Office, and he's been a leader for over 30 years in drafting Hawaii's energy code. His topic today is Reflections on Reflections, energy-saving coatings on buildings and homes. So let's give Howard a
round of applause. Good afternoon, ladies, gentlemen, distinguished audience. I don't know if I can handle this overwhelming crowd here, but I will give it the old college try. Reflections on reflectivity. Most of you were around a few years ago when we had an incredible heat wave. It was in September, school was in, and a photo that I will always remember was of a school kid in a classroom, and he looked very unhappy, and the paper in front of him was wet. Why was it wet? He was sweating in his own classroom. Hardly an ideal setting for learning. So the hue and the cry went up. Air conditioning, air conditioning, air condition all the classrooms in the state. What could possibly be wrong with this picture? Number one, we have something like 4,000 classrooms in the state of Hawaii, very few of which are air conditioned. So if we're going to air condition these, number one, we need to call up Hawaiian Electric and say, hey, I need a 220 line into this classroom. No 220 line. We have to get a brand new line coming in from Hawaiian Electric into the classroom times 4,000. Might that cost any money? Yes, it might. Do we have that kind of money? No, we don't. Problem number two, we get the line hooked up. Now we have to buy the air conditioning units. More cost. Then we have to install the air conditioning units. More cost. We get them running, and we find that the school's utility bill has very possibly doubled, if not more. Who is going to pay for that bill? Well, I don't know. There's no budget all the way down the line here. What could be possibly wrong with this picture? Plus, from my limited perspective, Hawaii was the first state in the union to declare the goal of 100% clean energy. Let's see, if we install 4,000 new air conditioning units, what's going to happen to our energy use? What's going to happen to our fossil fuel use? Up, 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 totally counter. to the goal that we set and which many, many other states have imitated. We were the national leaders in this field. So let's see, let me give my favorite analogy. We still have the heat pouring in to these classrooms. They're not well insulated at all. I liken that to putting an ice cube in an oven. The AC is going to be running like mad, and there's going to be cold air over here, but there's going to be heat surrounding it. Not a good solution. So what else can we do? We need to look at embodied energy. We in the energy field are looking not just at the used energy, but embodied energy. Let's see. Air conditioners are made mostly of metal and other electrical components. They must be mined. They must be manufactured. They must be distributed to the retail outlets. More energy used. And so then how do we keep classrooms, and in this case, I'm just using classrooms as an example for a much larger picture. What do we do to keep classrooms cool? Number one, we orient them so that the sun's heat shines mainly on the north and south faces. We reduce the amount of radiant energy going to the east and west faces because that's the most intense sunlight. Number two, we maximize windows on the north and south faces, minimize windows on the east and west faces. But you say the buildings are already sitting there. We can't do that. So now we're asking the question, what do we do with existing buildings to keep them naturally cool through passive design? In this case, as you probably gathered, I'm going to describe cool roofs and cool walls, where the exterior coating reflects back the radiant energy, the sun's heat, from the roofs, from the walls, plus you have high emissivity in those coatings. That means the heat that does enter that coating will re-emit back to the atmosphere so that very little of the heat gets into the interior space. We talk about reflectivity versus absorptivity. There are certain black shingles on roofs today. Black apparently is a very popular color, and it has a reflectivity of 0.5, meaning only 5% of the radiant heat striking that shingle radiates back. So all the rest is absorbed. The opposite is the cool surfaces that I was mentioning. On the market now is at least one coating product with a reflectivity rating of 0.93. 93% of the sun's heat is reflected back, and it has an emissivity of 0.75. So of the remaining 7% that gets into the coating, 35% re-emits to the atmosphere. Sounds pretty darn good. Now, what about resource efficiency? I mentioned the fact that air conditioners need to start with metals, plastics, and so forth, and get to the factory and back. You need to coat classrooms or other buildings with something anyway, something usually called paint. Instead of just regular old paint, why not use reflective paint? And they're on the market, and there is virtually no cost difference between a reflective paint or coating and a normal colored paint or coating. And yet another advantage is life. When you absorb a whole lot of the radiant energy, you are filling that surface up with UV rays. Why do I go to the dermatologist 3 months because as a fair-skinned person born and raised in Hawaii, who spent almost all his youthful days outside, I have many incidences of skin cancer, mostly of the benign type, and caused by the UV rays damaging the skin. So that is my argument for, oh, I didn't finish up in the materials resource. You need the coat anyway, coat the building. Why you're not using any additional material by coating with reflective surfaces. So that is my intro. Now I am active in an outfit called the Cool Roof Rating Council, and I helped found the Cool Wall Rating Council. I work very closely with these two directors here. Urban heat island effect. Pretty self-explanatory. When the radiant energy is falling on vegetation, the vegetation absorbs that energy and then reflects the energy through transpiration. And that results in moisture going back into the atmosphere and cooling the atmosphere down. Suburbs have a lot more vegetation. And then, of course, when you get into your urban areas, vegetation goes pretty well away, and that heat is absorbed so that your average temperature in an urban environment is much higher than the outlying areas. Oh, we talk about equity all the time. Turns out that neighborhoods occupied by disadvantaged groups, low income, have a lot less vegetation than do the more affluent neighborhoods. Some years ago, I was in El Paso, and I was up high on the ridge so that I could see most of El Paso and Ciudad Juarez across the Rio Grande. And it was winter, and the American side looked pretty gosh darn green, lots of vegetation. And the Mexican side was just this dull gray, partially because of smog. Everybody was heating their homes with kerosene, but also because there was zero vegetation. And guess what happens in summer? El Paso remains relatively cool. Juarez heats up like mad. So, urban heat island effect. Okay, reflectivity versus reflect absorptance. I described this already. The higher the reflectivity, the cooler the surface, the less heat there is to transfer into the living space. And again, I described emittance. Some heat is absorbed into the coating, but some gets re-emitted. According to the contents of the coating, TiO2, titanium dioxide, is the best reflective mineral to put into coatings. SR, solar reflectance, lower temperatures. Oh, here's a good example, 161 versus 114. There was an ad in our paper some years ago of a roofer guy applying white coating on a school roof. And before he started applying this was a hot summer day in Hawaii. The roof was 178 degrees. He applied the white coating. It went down to 104 degrees. If there's any engineers in the audience, they will immediately tell you that the delta drop was 74 degrees. Pretty gosh darn dramatic. This is California based. This is different times of day. Our hottest time of day is 2 in the afternoon. And just apropos of that, we have a greater solar incidence than it does even Tucson, Arizona. So that if we want to absorb the solar radiation, as in with the photovoltaic panels, we're in great shape. And indeed, we lead the nation in that regard. But when it comes to the importance of not letting that surface heat up to, in this case, 178 degrees, in comes reflectance. This is interesting. You don't need a white surface to have a high reflectivity. You see the 0.81, 0.88, those are the highest on the chart, but they're not glaring white. They're just plain old white. And then you get next over to the left, you have a lot of surfaces in the 60s. 60 is pretty darned good. The US Department of Energy has what are called Energy Star roofs, and they must have a reflectivity of 0.65. So you can see which of the roofs would qualify. And then the further to the left you go, the less and the less the reflectance, the greater the absorptivity. Hawaii was the first state in the nation to incorporate reflective roofs and walls into their own code. And since then, ASHRAE, USGBC, ASHRAE, all those codes now have reflective surfaces built right in. You get credit for reflectivity in these codes. And you see where, aside from ASHRAE 90.1, the I codes do not yet have that incorporated. I was working on the IECC 2021 and had managed to get reflectivity in there, but we are unable to adopt 2021 at this time. But it is making its way into the codes. These are all energy codes there. And green building certification, you probably are familiar with that. One of the criteria of green building certification is you must have reflective surfaces. Oh, we've been the Cool Roof Rating Council and Cool Walls, we're doing a heck of a lot of testing in Arizona, Ohio, and Florida. And of course, you're getting your best results from Arizona because you have the highest insolation incidence of solar radiation. And we're testing these models. These are, manufacturers supply their product and ask, what is the initial reflectance and what is the aged reflectance? And aged means that you have your paint samples out exposed to the elements for 3 years, and they are carefully monitored, and all conditions are equal. And we're just now beginning to come out with an extensive directory of which coating has which aged reflectors. We generally look at the aged because, of course, once you put the coating on, it's going to be sitting out there exposed to the elements. And you can't read all of this, but we are enveloping the reflective surfaces, both wall and roof, into the different codes and then voluntary. Yeah, now it's voluntary, but we will be making it mandatory as the codes become more stringent. And want to emphasize, there's no cost premium between a reflective surface or reflective coating and a normal run-of-the-mill type coating. And we're doing a massive educational program, getting these out first to engineers and architects, especially architects, because they are specifying the colors. And then we're going to move into school classrooms and certainly college classrooms. We're a fairly young organization, but our funding is increasing, our scope is increasing. Oh, and here are the two contact people. And hot off the press announcement, Audrey will be coming, and Sarah, the now director, will be coming to Hawaii for the PBX trade show, October 2nd, and they'll be presenting at the trade show, and then they are going to be visiting architectural engineering firms with one-on-one question and answer. And they will be, we have reserved the AIA meeting room on 4th Street Mall, and they'll be doing the in-person presentations there. And Hawaii Energy is probably going to co-sponsor meaning we're gonna have these seminars. We'll have one commercial, one residential, September 27th and October 1st. And it's over lunchtime. This is a lunch and learn. And because Hawaii Energy is going to be there, you will get a free sandwich for attending. So there's your motivation. Mark your calendars now. Oh, Urban Heat Island. Yes, let's go into that. Yeah, we have been blessed in Hawaii with this beautiful weather the last 2 years, but you heard it from me first. It ain't gonna last. We're gonna go back into the type of heat wave we had a few years ago. And when you have absorptive dark colors in the urban area, it gets hotter than blazes. So what we are working to do is get more and more light colors into the urban areas. And we haven't had, to my knowledge, health problems related to heat, but you will recall over the years, especially in August, we will read about, I remember there was 12 deaths in Chicago a few years ago. And last summer, Phoenix had, I think it was 13 consecutive days with temperatures 120 and over. So this is more as the Earth heats up, this is more and more of a problem, and we are working to ameliorate that, the urban problem, anyway, with reflective surfaces. And the hotter the surface, the greater the tendency to collect pollutants within that area. Oh, okay, the technology. This is kind of engineers in the room. This is kind of fascinating stuff. This is how we measure the effects of radiant energy on a surface. And good old emittance. Typical emittance for a coating is about 0.75. If we could boost that up to 0.90 or even 0.95, that would be terrific. It would vastly reduce the temperature. And this is how we measure the emittance. If you've been using solar reflective index, which is a combination of emittance plus absorptivity, that is good only for roofs, not for walls. And yeah, we mentioned the weathering. Yeah, Arizona, Florida, Ohio. And we're getting some very, very, very good results. And the product, this is all different manufacturers. And some are coming out testing very well after 3 years, some are not testing very well. But this is a voluntary program from the manufacturers so that they can tout their products. Yeah, generally speaking, the more TiO2, titanium dioxide, you put into the coating, the higher the reflective index. Yeah, here's the next generation. There is research, especially at Stanford University, which will devise a coating such that when it reflects back to the atmosphere, it does not get trapped in the atmosphere. As you know, our atmosphere is filled with carbon dioxide and a lot of other molecules. This new technology allows the heat to go straight into the atmosphere rather than heating up straight above the atmosphere into the cold universe rather than into the atmosphere. Very fascinating stuff. They're getting some promising results now. Stay tuned on that one. Yep, we have virtually all the paint manufacturers in the nation on the board with us. They're all CRRC members, and they know the importance of this, and they are all producing reflective products. Yeah, I didn't mention all these sustainable features. Low VOC, volatile organic compounds. I mentioned the life cycle. The cooler the surface is, the less susceptible it is to damage by UV rays. And reduce carbon footprint, not only by reducing the amount of energy used for cooling a space, but you don't need as much insulation or other heat mitigating technologies when you use reflective coating. And just to be up and up, so we know it's not just manufacturers touting their own product. The CRRC does require a third-party verification for all the measurements that are given out. And they're given out in a big, extensive catalog. And finally, yeah, just more samples of solar reflectivity. And these are primarily the darker colors. And they're, you can, by adding more TiO2 into a surface, you do get higher emittance, and then these numbers will go up. And that, I believe, is all the news that's fit to print. So I'll be deluged with questions now. Oh,
Okay, Howard, at this time, it's a pleasure to present to you this certificate of appreciation for your presentation on reflections on reflections.
Okay.
Very interesting.
All right.
Thank you so much.
yeah.
Well, thank you all for joining us, and we hope to see you next time at our next meeting, April 5th.
Engineers and architects of Hawaii welcome your comments on this program and any of our recent programs. We encourage your direct participation in this community outreach. So please email us your comments and ideas at eahawaii@gmail.com.